So picking up where we left off on Friday, we were talking about the inverse sine function. And don't stress about the inverse sine function. I'm not going to actually ask you to graph these on your test, okay? I may ask you to do it for your homework assignment, but I'm not going to ask you to graph this to master this for your test. We have enough going on with sine, cosine, tangent, cosecant, secant, cotangent without asking you to find the inverse or graph the inverses. Okay, so this is an exposure only. And the reason I want you to see it, though, is to know that we have to restrict this domain in order to make this possible. Because on a sine wave, it is not going to be a one-to-one if we let the domain go from negative infinity to positive infinity, because it won't pass that horizontal line test. Okay, so we're restricting the sine to be between negative pi over 2 and pi over 2. That way we can find angles whose sine are certain values. Okay, that's the whole goal of this, to explain what the arcsine and the arccosine and the arctangent are. Okay, so we're restricting the domain, negative pi over 2, negative 90 to 90. Okay, and we're asking ourselves what angle has a sine that is one half. So on Friday we said that was 30 degrees. Okay, pi over 6 is the equivalent in radians. What angle has a sine that is square root of 3 over 2? 60 degrees. That's pi over 3. Okay. So this is from our chart that we should be familiar with and comfortable with. We only have to know those 30, 60, 90s, 45s, the quadrantal angles for sine, cosine, and tangent. Okay. So we can ask you to do these things without a calculator. Okay. But something that is, a 10-degree angle, we're never going to ask you to do without a calculator. Okay. And then when we ask ourselves, can the sine ever have a ratio that is bigger than 1? Absolutely not. So this is not even possible. Okay. So back where we were yesterday, graphing the arcsine function, it ends up looking like this. And like I said, I might ask you to do it on the homework just so you're familiar with it, but I'm not going to ask you to do this for the test. Okay, so it's not one more thing to be worried about. But all it's doing is it's saying, hey, I'm restricted now between negative pi over 2 and pi over 2, and it's going to have this nice little elongated S kind of appearance. Okay? All right. So the other inverse trig functions, cosine oscillates just like sine does. So we have to restrict its domain if we want it to have an inverse function. And we're going to restrict that to 0 to pi. That way we have some positive values and we have some negative values. Okay, so this is restricted between 0 and 90 degrees. Okay, 0 and pi. And that's when we flip it, it will be an elongated kind of graph as well. Okay, so sine was restricted for the inverse, the arcsine, between negative pi over 2 and pi over 2. Cosine is between 0 and pi, so we get the full function. And then for arctangent, it's going to be between negative pi over 2 and pi over 2, just like sine was. So arcsine and arctangent are the same. The arccosine is the one that is just between 0 and pi. Okay? Thank you. So this is what the arccosine looks like. Okay? Instead of an elongated S, it's kind of the opposite, I guess. Okay? And notice that it's restricted between 0 and pi, so it's going to be higher. Because when we're at some negative values, that's just the way it looks. If you take the table and you transform it, switch the x's and y's around, that's what it's going to look like. Okay? And again, don't stress about what the graph looks like from a testing standpoint. You might be asked to do it on the homework assignment, but what we want you to remember is that we're restricting this domain between 0 and pi, 0 and 90, so that we can get the values whose angles have those ratios. Okay? And that's what the arctangent looks like. Okay? This one shouldn't be a big surprise because it was that odd function, right? that John Travolta-esque type of function. Okay, so it's going to look like that when we graph the inverse. Okay. So let's find the exact value if possible. Okay. So what angle is going to have, and again, these are our special ones, is either going to be 30, 45, or 60, or potentially our quadrantal angles. I've been talking, okay. But which one is going to be, which angle is going to have a cosine whose ratio is a square root of 3 over 2? A 30, okay? And this is positive, so we would just simply write 30 degrees. And if we want that in radians, we would say pi over 6. Anything over 6 is going to be a 30-degree angle in some quadrant. Okay? An angle whose cosine is negative 0.5. Okay? 0.5 is 1/2, right? So it's going to be a 60 somewhere, right? And we want it to be negative. So where was cosine restricted? Sine and tangent were between negative 90 and 90, right? Where's cosine restricted? 0 and, actually, let's go back. Let's find out. What did we restrict the cosine to have for a range? 0 and pi. So somewhere between 0 and pi, we want to know where are we going to get a half, okay? So we know that we are in the first or the second quadrant here, okay? Second quadrant, right? Okay, because that's where the cosine is going to be negative. What's a 60-degree angle in the second quadrant? What's a 60-degree angle in the second quadrant? 120, okay? So you may need to have your spinners out. You may need to have that table on your foldable that has those quadrant angles or those special angles, okay? Okay, so we asked ourselves, which angle does the cosine have a 1/2 for its value? Okay, so back to our table. We had sine, cosine, tangent, and there are some values that we're supposed to memorize. For 30, which is pi over 6, 45, which is pi over 4, and 60, which is pi over 3. Okay? Okay, so where's the sine equal to, or what is the sine of 30? Sine of 30? 1/2. Okay? Sine of 45? Sine of 45. Square root of 2 over 2. Sine of 60? Square root of 3 over 2. Remember, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. If we put our 90 in here, that's our square root of 4 over 2. And 0 is a square root of 0 over 2. That table we filled out last week. Okay? These are just reversed. Cosine is going to be square root of 3 over 2 at 30, the same at 45, and 1/2 at 60. Okay? And tangent is going to be sine over cosine, or think about the 30s as having all those 3's. Okay? And then sine over cosine, sine over cosine. Okay? So you've got to have this table down so that you can quickly come up with this information. So there's 9 values that we want you to know off the top of your head. Okay? So now when we look at this guy, we have, where's the cosine of square root of 3 over 2? Well, here's the cosine that's square root of 3 over 2. That's a 30-degree angle, or pi over 6. Okay? Where is the cosine going to be a negative 1/2? Well, it's a positive 1/2 here at 60. Okay? So we have to find this place where it would be negative between the values that it is restricted to. we have a domain of 0 to pi over 2, or 90. So we have to have a 60-degree angle in this quadrant for the cosine to be negative. Yep. So a 60-degree reference angle here means that if this is 60, this little guy up here is 60. I gotta draw it better. Okay, then this angle had to be 120 degrees. Okay, and then you can give the equivalent of, let's see, pi over 6, 2 pi over 6. Actually, that's a 60, so 2 pi over 3. Okay. All right, so then part C, we're asking, where is the tangent? What's the arctangent inverse tangent of square root of 3 over 3? In other words, where in this table does the tangent get to be square root of 3 over 3? 30 degrees or pi over 6. Okay. So far so good now? Now that we know where these numbers are coming from? Okay. These are all things that we can ask you to do without a calculator, because we expect you to memorize those 9 values. Okay. Now, where's the tangent going to be a positive 1 at? 45, pi over 4. So we're asking what angle measure when we're using the inverse sine or the arc sine or the arctangent, inverse tangent, arc cosine, inverse cosine. Does that make sense to everybody? Okay. If I had asked for a negative value here, then we would want that to be a 45-degree angle at in the 45-degree angle in one of these 2 quadrants, quadrant 1 or 2, 4. Okay. So tangents restricted, arctangents restricted to quadrants 1 and 4 because it's negative pi over 2 to pi over 2. Sines restricted to those 2. Cosines restricted to quadrants 1 and 2. The arc cosine. Okay. So far so good? Okay. Now, we can also ask you to find these values to 3 or 4 decimal places using your calculator. Okay. Whenever we see something without a degree symbol, we're going to have to assume radians. Okay. So they'll put degrees in there if it's degrees. Otherwise, you assume radians. Okay. So we'll break out our calculator. And we're asked to find the arctangent of 1.9. So you want to make sure that you change your calculator to radian mode. And then I'm going to quit. And I want the arctangent of 1.9. Where's my arctangent button? Don't have one that actually says arctangent. So what's the equivalent of arctangent? Tan negative 1, right? The inverse tangent. So it's the second of your tan. So you're going to press second tan, and then you want to put a 1.9 in there. And you should get 1.086. Did everybody get 1.086? Radian mode, second tan, 1.9. Okay? All right, second example says to find the arc cosine of negative pi over 3. Okay, we could do this without a calculator, right? Okay, we should know this value, but let's find out for sure what it is. So negative pi over 3, we're going to use the second cosine, and then we're going to put a negative, use your negative sign, not minus, and then your pi is the shift of your caret key, divided by 3, close parentheses, and it gives us an error. Okay? Why did it give us an error? Okay? What happens if we insert parentheses around it? Okay? Still gives us an error, right? Okay, why is it giving us an error? Calculator knows something we don't know? Why not? Yes, it's outside of our restricted range, right? Our cosine says that we can only be, our domain for our inverse function here is from 0 to pi. Okay? We didn't say anything about negative pi over 3, right? So this is not even defined between, at negative pi over 3. It's defined between 0 and pi. So we would say undefined. Okay? Not possible. Okay? Sine was restricted between negative pi over 2 to pi over 2 for the arcsine. Cosine was between 0 and pi. And tangent was between negative pi over 2 and pi over 2, like sine, the arcsine. Okay? So now we're ready for the angle whose sine is, and plug this in. And we get negative 1.165 radians. Okay? Had you put this into degrees, you would get all these values back in degrees. Does that make sense? Okay? We have a ratio here. We want to know whose sine or angle whose sine is this. So let's change that to degrees to see. If I go to mode and I change it to degrees, okay, and I do a quit and I do repeat of what I just did, this is a negative 66.78 degree angle, negative 1.166 in radians. Does that make sense to everybody? We have a ratio for the tangent. The opposite over the adjacent is 1.9. Tell me the angle who has that ratio. This happens to be in radians. Okay. Everybody good? All right, we know how to do it mentally and also with our calculator. All right, so inverse properties, composition of functions. Again, I'm not going to assess you over this, but I want you to be exposed to it so you're ready for it in calculus. Okay? So if x is between negative 1 and 1 inclusively, and y is between negative pi over 2 and pi over 2 inclusively, then the sine of the arcsine is going to be x. If we compose a sine with an arcsine, a sine with its inverse function of some value, you'll get that value. And the inverse sine of the sine of y is going to be y. Okay, they're just inverses of each other, so when you compose them together, you should get whatever they were operating on. Okay, if x is between -1 and 1 inclusively, and y is between 0 and pi, okay, then the cosine of the arc cosine of x is going to be x, and the arc cosine of the cosine of y will be y. Okay. And likewise, we do the same thing with tangents, have the same restrictions as the sine and arcsine, and we'll get the same values back. Okay. Those are the inverse properties. So if possible, find the exact value. What's the tangent of the arctangent of 23 going to be? 23. The sine of the arcsine of pi? Okay. Is pi allowed? Okay. Angle whose sine is pi. This one's not possible, right? Okay. And then what about the cosine of the arc cosine of -0.820? These we're basically going to be looking at them and figuring them out. Yep. So this one's going to be -0.820. Okay. We just have to ask ourselves, we don't want to just immediately put something in here, right? Okay. It's possible for an angle to figure out what angle has a ratio of 23 for tangent, right? Because tangent gets very, very large. Okay. And if we take the tangent of that angle, we're going to get whatever this was. But it's not possible to take the arcsine of pi because we're restricted, aren't we? Between -pi/2 and pi/2. And we're saying, tell me an angle whose sine is this number. Okay? We're outside of our domain here. But this one, we're okay again. Okay? And we plug it in. All right. So an exact value of this one. Okay. An angle whose cosine is 2/3. What we're looking for here is where would my opposite over hypotenuse be 2/3, right? Adjacent. Cosine. Adjacent over hypotenuse be 2/3. Okay. Once we find that angle, for what value of theta is adjacent over hypotenuse 2/3, once we find that, let's take the sine of that theta. Okay, so let's take the arc cosine of 2/3. Okay, so the arc cosine of 2/3 says inverse cosine 2 divided by 3. Okay, that's a 48-degree angle. In degrees, we're going to take the sine of that value, and we get 0.745 to 3 decimal places. Okay, so when you think of arc anything, think of what angle has this for its sine or cosine or tangent. Okay. All right. So 26 problems, you'll have the answers for half of them because the odds have answers in the back of the book. Okay. And this we were trying to finish up last Friday. So I want to go over just a few examples from section 4.8. And we'll have a work day tomorrow to finish things up, but also to review for our test and to take that quiz. Tomorrow is a long block period, 90 minutes. Okay, so we've got a double day tomorrow. Quizzes tomorrow over those graphing. Yep, yep, and we're reviewing as well. Yep, yep. Okay, so this is this one. Now let's switch gears and talk about 4.8 just for a moment. Let me save this, and let's open 4.8. Okay, so the whole point of Trig is to be able to apply it, okay? To be able to model things, to be able to figure things out from it. And that's what we want to talk about, just a couple examples on how we do that. So first of all, if I asked you to solve this right triangle, where A is 40 and B is 27, 40-degree angle, little b, the side opposite angle B, is 27. When I say solve the triangle, what am I asking you to do? Figure out everything. Okay, we know C is 90 degrees. I'm not going to ask you to tell me that angle C is 90 degrees. Okay, so 50. Angle B is 50. I like that. Supplementary, right? Well, the triangles are so complementary to angle A. Okay, now, in case you made a mistake, I always work with the two pieces of information that I was given. Okay, so I don't usually use that 50-degree angle to do anything. Okay, so we need to find little a and little c. How do we find little a? Okay, so we're saying we have an angle that is 40, so we don't want to use an inverse tangent. Okay, if we weren't given any angles whatsoever, we would use that. Okay, but we are going to say tangent, right? Tangent of 40 is the opposite over the adjacent. So what do we have to be in? What mode? Degrees, because this is a 40-degree angle. And you would take the tangent of 40 times 27. And find it to 2 decimal places. Okay, somebody who's quick on their calculator, what do we get? Let's wait until we finish with this, please. Okay. Someone who's quick on the calculator? 22.655, so 66. Okay, that's about equal to A. We had to do some rounding, so it's not an exact value. The quiz itself tomorrow is over just graphing. Graphing sines, cosine, tangent, cosecant, secant, cotangent. Okay. All right, so how would we find C? We could use Pythagorean theorem, hoping that our A is exactly right. Absolutely. Or we could say this is a hypotenuse and I've got an adjacent to 40, so cosine of 40 is the adjacent over the hypotenuse. Okay. Cross multiplying here, C times the cosine of 40 is 27. So I want to get the C by itself. C will be 27 divided by that cosine of 40. Okay. And you would calculate that to 2 decimal places. All right, so what's happening here? Very hard to see. There's a kid down here holding a string, and that string is coming up here to a kite. Okay, so there's a kite way up there. So a kite and a kid. Find the height of the kite if all 50 feet of the string is out and the boy's hand is 3 feet up from the ground and the angle of elevation is 34 degrees. Okay? Angle of elevation. What angle are we talking about? That one down here. So 34 degrees. Okay, that's not 340. Try that again. Angle of elevation is 34. The string is 50 feet. That does not show up very well. And we're trying to find the height of the kite. Okay? And he's 3 feet tall. So whatever height we get, we're going to have to add 3 feet. Or his hand was 3 feet up. Okay? So which one are we going to use? The sine inverse, or the sine, yep, angle who's the sine of 34. So sine 34 equals h over 50. Whatever we get, we're going to add 3 feet to the end. We're going to take the h by itself, so we're going to cross multiply. 50 times the sine of 34 will be equal to our h. So 27.96 plus 3 is 30.96 feet. Okay, make sense? Okay. Because he was 3 feet tall, so we have to add 3 more feet to the yes, he's 3 feet here, and it's 3. We have to add that 3 feet. Here's our 90-degree angle, and this angle of elevation is compared to the ground. Okay, when you measure those, you can use a gravity protractor to figure out what the angle is. Okay. All right, another application. Okay, here's a crazy lady cleaning windows. It's hard to see it. We've got a ladder. Okay, some rose bushes where you likely don't want to put your ladder anyway because it's not usually very flat, right? Okay, the ladder's 10 feet long. It's leaning against the side of the house. Find the height h from the top of the ladder to the ground if the angle of elevation of the ladder is 69 degrees. Same kind of problem, right? Angle of elevation, 69 degrees. How tall, how high up that house are we able to reach? Sine of 69 equals h over 10. Why the sine? Opposite over hypotenuse. And this is not the hypotenuse. This is the HEI GHD. So don't get confused by that. We usually use C for hypotenuse. Okay? All right, setting up another one. From a point 20 feet in front of a house, the angles of elevation from the base of the chimney to the top of the chimney are 37 and 45 degrees respectively. Find the height of the chimney. Okay? Now we've got a house. Didn't have a picture of my house with a chimney on it. Okay? Here's the start of the chimney. Here's the top of the chimney. Okay? From a place 20 feet away, we have an angle of elevation to the base of the chimney that is 37 degrees, and an angle of elevation to the top of the chimney that is a total of 45 degrees. How can we find the height of the chimney? Does it matter how far in that chimney is to the house? As long as we're 20 feet, I guess this has to be 20 feet total. Good question. Okay, so 20 feet from where that chimney starts. Absolutely. Find the big height and subtract the smaller height. So you've got two sine or cosine or tangent. Okay, we're looking at adjacent, right, and opposite. So opposite and adjacent, we're dealing with tangent here. Yep. So 2 tangent problems. Find the large height using the 45-degree angle. Find the smaller height using the 37 and subtract. Everybody good with this? So tangent of 45 will be h1 divided by 20. So we're going to take that tangent of 45 times 20 to get our h1. And tangent of 37 will be our h2 over 20. So we're going to take the tangent of 37 times 20 to find h2 and then subtract. Okay? All right. Angle of depression. We need to see one of those. Okay? Got an airplane, 240 feet high. Okay, please, gentlemen. Airplane, 240 feet high, 5,200 feet from its landing runway. If it's descending in a straight line to the runway, determine its angle of descent. Okay? So we've got a small plane up here. Not very good at drawing planes. Okay? There's our plane. It is 240 feet high. And it is 5,200, and this is not going to be to scale by any way, shape or means, from its runway, right? Okay, so it is now going down at some sort of angle of depression, and this is by all means not to scale. Okay, that would be a very steep descent. Okay, so this is not going to be the right answer. All right, good. We've got an adjacent and a an opposite, right? So we're going to use the tangent function here, okay? And we're trying to find out this angle of depression here, aren't we? Okay, so we can invert this triangle to be 240 here, right? Okay, so we have an opposite and an let's see, adjacent. So the tangent of that angle is going to be 240 over 5,200. So we need to use the 240 divided by 5,200 equals, and then the inverse tangent to find the angle who makes that. And it should be a smaller angle than what this looks like. What you come up with? 2.634? Yeah, this is way off of scale. So 2.634 is our number of degrees, which is good, right? We wouldn't want to go at a 45-degree angle by any means or something like that. We want a little nice cushion. So you're going to take your 240 divided by 5,200 equals, and then do the inverse tan, the arctan of your answer. They got it on the calculator? Knows how to do it? I think it should be 2.63. So 240 divided by 5,200. Put my calculator up here. All right, so it's still on the other one. But if we take 240 divided by 5,200, and we say, hey, tell me which angle has that answer. So we do second tan and then second answer to pull that answer that is in memory for us. Are you in radians? And that's okay. You can just make sure you tell me it's in radians. We just happen to be in degrees for the other ones. Okay. So we're doing the inverse tangent on this one because we want to know what angle makes that ratio. Because now we have an opposite and a hypotenuse, we don't know what the angle is. most of the time we've spent learning about those, taking those angles and figuring out what a side, a missing side was. But this is one time when we want to know what that angle is when we've got the two sides. Okay, so the arctangent says, tell me the angle whose tangent is this ratio. Okay. All right. So doubling up on assignment. We'll have some time to work it, and we'll have a review sheet tomorrow. So a lot going on tomorrow. We'll see how much we can accomplish. Okay. Work some tonight so you're ready and prepared to come back with questions.